Mercury. The very name conjures up images of speed and celestial flight. This tiny world, the smallest of our planetary family, flits around the sun with astonishing swiftness. It's no wonder the ancient Romans named it after their fleet-footed messenger god. In the grand tapestry of our solar system, Mercury is a tiny jewel, shimmering close to the sun's glare. But don't let its size fool you. This little planet harbors secrets that have captivated astronomers for centuries. Imagine a world smaller than our own moon, its surface a tapestry of greys and charcoal hues. That's Mercury. This tiny planet, often overlooked in the grand scheme of our solar system, holds secrets and stories etched into its rugged terrain. This diminutive planet, just a third the size of Earth, is a world of stark contrasts. Despite its small size, Mercury's gravitational pull is surprisingly strong, a testament to its dense, iron-rich core. Its surface, heavily cratered and ancient, resembles our moon in many ways. These craters, some spanning hundreds of miles, tell tales of countless impacts over billions of years. But unlike the moon, Mercury shows signs of a more dynamic past. Evidence suggests that the planet has experienced significant geological activity, reshaping its surface multiple times. Vast plains of solidified lava speak of a time when volcanoes raged across its surface. These volcanic plains, now frozen in time, are a window into Mercury's fiery past. Towering cliffs, some stretching hundreds of miles, hint at tectonic forces that once reshaped this tiny world. These cliffs, known as scarps, are believed to have formed as the planet's core cooled and contracted, causing the surface to buckle and crack. And everywhere, the sun's relentless heat has left its mark, baking the surface and leaving it dry and airless. With temperatures soaring to 800 degrees Fahrenheit during the day and plummeting to minus 290 degrees at night, Mercury's environment is one of the most extreme in the solar system. This harsh climate has stripped away any atmosphere, leaving a barren, desolate landscape. Mercury's orbit is a celestial ballet unlike any other in our solar system. It's a dance that defies the conventional rhythms we see in other planets. It's a whirlwind waltz around the sun, completed in a mere 88 Earth days. This rapid journey means Mercury experiences more sunrises and sunsets in a single Earth year than any other planet. This makes Mercury the fastest planet in our solar system. Its speed is a testament to the gravitational pull of the sun, drawing Mercury into a tight, fast orbit. But here's where things get really interesting. Despite its rapid orbit, Mercury's rotation on its axis is incredibly slow. Mercury's day, the time it takes to rotate on its axis, is a leisurely 59 Earth days long. This slow spin means that one day on Mercury is almost as long as 2 of its years. This means that for every 2 orbits around the sun, Mercury rotates on its axis only 3 times. This unique relationship is known as a 3-to-2 spin-orbit resonance. This unique 3-to-2 spin-orbit resonance is a celestial quirk that sets Mercury apart. It creates a fascinating dynamic where the planet's day and year are intricately linked. Imagine a world where the sun rises in the east, then slowly moves back towards the west before rising again. This peculiar motion is a direct result of Mercury's unusual spin-orbit resonance, making its sky a constantly shifting canvas of light and shadow. The sun's dance in Mercury's sky is unlike anything we experience on Earth. It's a reminder of the diverse and wondrous mechanics that govern our solar system. Mercury's unique dance out of time is a testament to the complexity and beauty of our cosmic neighborhood. Each planet, with its own rhythm and pace, contributes to the grand symphony of the solar system. Mercury has been known to humanity since ancient times. Its close proximity to the sun made it visible to early skywatchers who tracked its movements across the heavens. The ancient Babylonians, Egyptians and Greeks all had their own names and myths for this elusive celestial wanderer. But it wasn't until the development of the telescope that we began to unravel Mercury's secrets. In the 17th century, Galileo Galilei was among the first to observe Mercury through a telescope, though his view was limited by the technology of the time. It wasn't until the 20th century that we began sending spacecraft on daring missions to this enigmatic world. Section 5, Mariner's Voyage and the Messenger's Revelation. Our understanding of Mercury took a giant leap forward in the 1970s with the arrival of NASA's Mariner 10 spacecraft. This mission marked a significant milestone in space exploration, as it was the first time humanity had sent a probe to study the innermost planet of our solar system up close. This plucky probe, the first to visit Mercury, flew past the planet 3 times between 1974 and 1975, capturing the first detailed images of its surface. Each flyby brought us closer to understanding the mysteries of this enigmatic world, providing invaluable data that would shape our knowledge for decades. Mariner 10's images revealed a world more moon-like than we had imagined, its surface covered in craters and vast plains. These images showed a planet that had been heavily bombarded by meteoroids, much like our own moon, suggesting a violent history. But it wasn't until NASA's Messenger spacecraft arrived in orbit around Mercury in 2011 that we truly began to appreciate the complexity of this tiny world. Messenger's mission was to delve deeper into Mercury's secrets, and it did so with remarkable success. Messenger, short for Mercury's surface, space environment, geochemistry and ranging, spent 4 years orbiting Mercury, mapping its surface in unprecedented detail and unlocking many of its secrets. The spacecraft's suite of scientific instruments allowed it to study Mercury's composition, magnetic field and tenuous atmosphere, providing a wealth of data that has transformed our understanding of the planet. From discovering water ice in permanently shadowed craters to revealing the planet's volcanic past, Messenger's findings have painted a much richer and more complex picture of Mercury than we ever thought possible. Section 6. Hidden Depths. Messenger's observations revolutionized our understanding of Mercury. It discovered evidence of past volcanic activity on a scale far greater than previously thought. Vast plains of smooth volcanic plains, larger than some of Earth's continents, hinted at a time when Mercury was a hotbed of geological activity. But perhaps the most surprising discovery was the presence of water ice at Mercury's poles. Hidden deep within craters where the sun never shines, Messenger found evidence of vast deposits of water ice preserved for billions of years. This discovery challenged our assumptions about the inner solar system and opened up new possibilities for future exploration. Section 7. A window to the past. Studying Mercury isn't just about unraveling the secrets of this one small planet. It's about understanding the formation and evolution of our entire solar system. Mercury, as the closest planet to the Sun, holds clues to the earliest days of our cosmic neighborhood. By studying Mercury's composition, its magnetic field, and its unique orbital dance, we can learn more about the processes that shaped the planets we see today. It's like looking back in time to a time when our solar system was young and full of possibilities. Section 8. Planetary puzzles. Despite all we've learned about Mercury, many mysteries remain. Its unusual density, the highest of any planet in our solar system, suggests a large iron core that makes up a significant portion of its interior. But why is Mercury's core so large compared to its overall size? And what about its surprisingly strong magnetic field, a feature not shared by its larger, rocky cousins, Venus and Mars? These are just a few of the puzzles that continue to fascinate scientists and drive further exploration of this enigmatic world. Section 9. The Quest for Knowledge. The quest to understand Mercury is far from over. In 2018, the European Space Agency and the Japan Aerospace Exploration Agency teamed up to launch BepiColombo, a mission that promises to unlock even more of Mercury's secrets. BepiColombo, named after Italian mathematician and engineer Giuseppe BepiColombo, consists of 2 spacecraft that will orbit Mercury in tandem, studying its interior, surface, and magnetic field in greater detail than ever before. The data from this mission is expected to revolutionize our understanding of Mercury and its place in the solar system. Section 10. Our place in the cosmos. As we continue to explore the cosmos, planets like Mercury remind us of the incredible diversity of worlds that exist beyond our own. Each planet, with its own unique story, teaches us something new about the universe we inhabit. Mercury, the swift messenger, may be small, but its story is far from insignificant. It's a story of extremes, of ancient violence, and of surprising discoveries. It's a story that continues to unfold, challenging our assumptions and inspiring us to look deeper into the cosmos, seeking answers to the universe's greatest mysteries.